Okay then, this chapter is all about graphs, and I'm going to teach you today about how to plot graphs. We usually say that the horizontal axis, it has a special name. The horizontal axis always has the name x-axis. It's very important you remember that. The vertical axis of a graph also has a name, y-axis. This point here in the middle is 0, and that has a special name as well. This point is called the origin. The starting point of the graph, okay? And this point has two coordinates. It means that the x-axis is in 0, but the y-axis is also at 0. So it has a coordinate 0, 0, and it's called the origin. And it's important to remember that name. So these are the basic terms. In Swedish, almost the same. Okay. Then what we can do then is we need how to be able to plot a graph. So I've put some equations here. Here is the equation y equals x. And how are we going to plot that? Well, we actually just set up a little table here. X, y. And we're going to plot the coordinates, the straight line graph y equals x. How do I know it's a straight line? Well, because there's only an x term in here. Y is expressed as a term of x. If it had been expressed as x squared, it wouldn't have been a straight line. But because it only has x or 2x or 3x or minus 4x, if there's only one power of x, so if there's an x term, not an x squared term or an x cubed term, it's always going to be a straight line equation. Okay? So let's put in some simple values of x. Let's see what happens to y when x equals minus 1. Let's see what happens to y when x equals 0, and let's see what happens to y when x equals 1. So I'm giving x a number. Okay, so if x equals minus 1, because y equals the same as x, then y must equal minus 1. When x equals 0, if we place this with 0, what would y equal? It would equal the same, 0. If x equals 1, then y is going to equal the same, so of course it's going to be the same number. In order to plot a straight line equation, you only need 3 coordinates. And then that's all you have to have. 3 coordinates to plot a straight line. Let's have a look. Let's take away here. So first, before we can do anything, we actually have to fill in our axis. This point here is 0, the origin. Let's say we go 1, 2, 3, 4, 5. I've made each of the distances between here 10 centimeters. So when you draw an axis to scale, it's important that the distance between each number is identical. And here, minus 1, minus 2, minus 3, minus 4, and minus 5. And likewise, my y-axis, I've decided to use this exactly the same scale. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, and minus 5. So I know that this equation is actually meeting at the point minus 1, minus 1. So that means I have to plot this coordinate, minus 1, minus 1. That means the first letter here means, what's my x coordinate? The first number of plotting a coordinate is always the x number, the one you do on the horizontal axis. The second number in a coordinate is always the y number. So I'm now going to plot the coordinate minus 1, minus 1. To plot the x coordinate minus 1, it means I go along minus 1 on the x scale. And then the y coordinate minus 1 means I go down minus 1 on my y scale. So I get my first point of my graph here. Then I know that I have another coordinate, and that's 0, 0. And this one is also on my line. That one's nice and easy because it's slap bang here in the origin. And then I could plot the coordinate 1, x equals 1, y equals 1. That is represented like this in maths terms. The coordinate 1 in the x and 1 in the y. So I go 1 along in the x coordinate and 1 up in the y coordinate. And if I do it properly, it should be here. I now have 3 points, and it means I can plot, fill in my line. Should go through all 3 points. And I have now plotted the line that represents the equation y equals x. And that's all you have to do to plot a graph. Okay, let's have a look at what happens then with another graph that's similar, but we'll draw it in a different colour. My next graph was y equals x plus 2. So we do exactly the same thing. Make up a little table of x and y. Take 3 values of x. We can take, instead of minus 1s, we can try and avoid those if we don't like negative numbers. We can take x as being 0, 1 and 2. And this time we are plotting the graph y equals x plus 2. So when x equals 0, what's y going to equal? Well, y would be the same as 0 plus 2, because x equals 0. So y now has a value of 2. In this one, y equals x, but we know that x equals 1. 1 plus 2. So y will be 3. And here, 2 plus 2 will give us 4. So we now have our coordinates. When x is 0, y is 2. X is 1, y is 3. So y is always just going to be 2 more than x was. So now we can plot those coordinates. This one will give us the coordinate 0, 2. This one will give us the coordinate 1, 3. And this one will give us the coordinate 2, 4. And we'll plot them on our graph. 0 on the x direction means we'll be here on this line. Somewhere on this line there's 0 moving in the x direction. And 2 up. That's our first point. Then we have 1 and 3, which will be here. And then 2 and 4, which will be here. We only need 3 points to plot a straight line equation. And then use our ruler and draw a line through all of the points. And now we have plotted the graph that represents the equation y equals x plus 2. What can we say about these lines? Do you notice something special about them? What do we call the name of the lines when they're like that?
They're parallel.
They're parallel. So these are 2 parallel lines. The reason that they are parallel is because they just have x in front of them. They both have 1x in front of them. If this one had had 2x in front of it, it wouldn't have been parallel. It would have been much steeper. So the reason that they're parallel is because they both have 1x. So y equals 1x on one and y equals 1x plus 2 on the other. So parallel lines, if they have the same number in front of the x, they'll always be parallel. Okay, what more can we say? Well, this graph went through the origin. And it's a straight line. It's continuing the same amount the whole time. So this graph, this particular line here, has a very special name. If it goes through the origin, which this one does, we say that this graph is proportional. It goes through 0 and it increases the same amount every time. And it's the same word in Swedish, I think. Proportional. I think it is, yeah. And then this graph then, does this one go through the origin? No. So it's not proportional. So any graph that does not go through the origin, even if it's a straight line, is called non-proportional. Any graph that does go through the origin is called proportional. Okay? So now we've seen that there's quite a big similarity between the equation y equals x and y equals x plus 2. Let's plot a new graph then, and we'll take a different colour. I'll try and make a bit of space here, take all my words away. So I'm soon running out of colours here, but we've got, we can plot the next graph, y equals 2x. Equation y equals 2 lots of x, and again, we just take 3 simple values of x, and you can decide whichever values you'd like. Let's take 0, 1 and 2, because they're really easy. And when x equals 2, we want to know what y is going to equal. When x equals 2, y equals 2 lots of x, which is 2 times 2, because we know that x equals 2, so we're going to get 4. Y equals 2 lots of x, but now x equals 1, 2 times 1, it's going to be 2. Y equals 2 lots of x, but x is 0, so 2 lots of 0. So plotting these graphs is actually quite easy. This will give us the coordinate 0, 0, 1, 2, and 2, 4. Let's plot them on our graph. To plot the coordinate 0, 0, it's nice and easy. It just goes through the origin. 1, 2, 1 along on the x and 2 up on the y. Here. And 2 along on the x for the next point, and 4 up on the y, it will be here. So when we then, 3 points we need to do our straight line equation. Why 3? Because if I've done one of them wrong and I've only got 2, my whole line will be wrong. But if I've got 3, my line should go through all 3 points, and I'll be able to see if I've made a mistake on any of the points. And as you can see, my line goes through all 3 points, so therefore I've done it right. And this is then the equation. This line represents the equation y equals 2x. What can we say about the equation y equals 2 lots of x compared with y equals x? Well, y equals x goes 1 up for every 1 along, 2 up, 2 along, 3 up, 3 along on this graph. But this one is twice as steep. So it goes 1 along but 2 up, 2 along, 4 up. So we can see that the larger the number in front of x, the steeper the graph will go. If we'd had y equals 3x, would go along 1 and up 3, it would make it even steeper. Along 2 would go up 6. So the number in front of x tells us how steep the graph gets. Right, we'll plot the next equation in the same colour because it's a little bit related to y equals 2x. It's related by the equation y equals 2x minus 4. X coordinate and y coordinate as before. When x equals 0, 1 and 2, we'll take those because they're nice and easy. Y equals 2 lots of x, 2 lots of 0, minus 4. Well, anything times 0 is 0, so we get 0 minus 4. Y is going to equal minus 4 at this point. When x equals 1, 1 times, 2 lots of 1 minus 4. 2 lots of x minus 4. 2 minus 4 is minus 2. 2 lots of x, 2 times 2 minus 4. 4 minus 4 is going to give us 0. So when we plot this graph, it's going to be very different. We have starting at 0 on the x, minus 4 on the y. The first point. 0 on the x, minus 4. When x is 1, y is minus 2. When x is 2, y is 0. So we have a new graph related to the first one because I haven't written it very well. Why is it related to the first one? Well, because it's got the same value of x in. This one had 2x in. 2x minus 4, and this one also had 2x in, but 2x. So we'd expect these lines to be parallel. Are they parallel? Yes, they are. So y equals 2x minus 4. Is this one proportional? No, it isn't, because it doesn't go through the origin. Is this one proportional? Yes, it is, because it does go through the origin. There's one more graph I'm going to show you, and after that it's going to get too messy. But it's important that I show you what happens with a graph that has a minus number in front of the x then. So let's plot the graph, and I have one colour left. Y equals minus x. And we use the same rule as before. We put up some coordinates of x and y. Let's take some simple values of x, 0, 1 and 2. And we now say that y equals minus whatever the value of x was. So this is easy. Minus 0 and 0, it's the same thing. But y is minus x. Well, if x is 1, y must be minus 1, the negative of it. If x is 2, y must be minus 2. So let's plot this graph. First coordinate, 0, 0 again. Second coordinate, x is 1, but y is minus 1. Here. X is 2, but y is minus 2. Here. No. I should be using my ruler. Okay, let's plot this graph then. Y equals minus x. Very, very similar to y equals x. Here's y equals x. If we were to draw an angle, if we were to measure the angle between y equals x and y equals minus x, it would be exactly 90 degrees. This one, you can imagine that you're going up the mountainside. So anyone that has a positive gradient, think of yourself as being a little backpacker climbing up the mountain. Okay? Always going upwards if there is a positive number in front of x. So any graph with y equals x, y equals 2x, y equals 3x is going to have this direction. Whereas any graph with a negative number, it's like coming down the mountainside. It's always going to have a slope in this direction. And that's an important thing to remember. That any gradient, any equation, any line coming in this direction, a downward slope, that has a negative number in front of x. Whereas anyone with a positive number in front of x will always have this direction of slope. What if I was to plot the coordinate then, plot the line around when x equals 1? Is there any line here when x always equals 1? Well, yes, there is. If I was to make a line along here, doesn't matter, sorry, that's the wrong one, when y equals 1. This line here can be represented by y equaling 1. Let's do one where represented by the line x equals minus 1. At this line here, the value of x is always minus 1. The value of y can change, but the value of x, any point on this line, is always minus 1. Whereas the value of y on this line is always equal to plus 1. It could have the coordinate 2, 1, or 3, 1, or 4, 1. There's lots of different coordinates, but the value on this line is always that y equals 1. So there's lots of different ways we can present and work with graphs. The important things to remember are plotting coordinates. That here we have the x coordinate is always first. The y coordinate is always second. We have to remember our important word for the 0, 0 point, the origin. We have to remember that any graph that goes through the origin and is a straight line is called a proportional graph. What else are the main key points. We have to remember the equation of the line, and then what do we call this point here where it actually cuts, not through the origin, but it cuts somewhere higher up. This point here is called the intercept. It's the name of where the line cuts the y-axis. So it's the intercept point. That's another important term for graphs. And then there is, and notice that at the equation here, y equals x plus 2, cuts the graph at plus 2. So if I was to give you an equation here, y equals x plus 2, the number here tells me it's going to cut the y-axis at plus 2. So I could put that point in already directly. So the intercept is very important, this last number here after the equation. And then the other thing that I'll do another video on to show you is if I was to give you a graph like this and say, I want you to work out what the equation of the line is, you can do that by working out how steep the slope is. And how steep the slope is will give you what number should be in front of the x. Should it be a 1 or a 2 or a 3 or a minus 1 or a minus 2? And this, how steep the line is called the gradient in maths terms. The gradient of the line is how steep that particular line is. So this one has a steeper gradient than this one. It has a steeper angle going upwards. There's a higher number in front of this x, 2x, than there was in front of this one here, was only 1x. So the gradient of the graph is how steep it is. And they're all the terms that you need for being able to plot graphs.